All right, so last we left off, we did a Rolles theorem problem. And here's another one example just to keep you cruising. So it says use Rolles theorem to find all values of c such that f prime of c equals 0 for this equation on the interval from -1 to 3. All right, so with Rolles theorem, we have two steps. One, we want to check the endpoints. Okay, I want to see if f of -1 comes out to be the same thing as f of 3. I want to see if they start at the same height and end at the same height. So if I plug in a -1, it makes this a 0 and the whole thing's a 0. If I put a 3 in here, it makes this a 0 and the whole thing's a 0. Okay, so check. Now we move on to step 2. We want to find all the cases where f prime of x equals 0. So since it starts and ends at the same height, we got to find f prime of x. Well, that's a good old product rule with a ninja rule, right? Oh man, brings back some memories. Some of you guys are good at this, and other you need to go back and do some work. All right, so if this is my u and this is my v, when I do my derivative, it's u prime, that's a 1, times v, plus v prime, oh, that's a ninja rule, 2 times this thing to the first, times the derivative of the inside, which is a 1, times u, which is x minus 3. So I just got to multiply this stuff out. Remember, all right, this one is x plus 1 times x plus 1. This one's going to be 2 times x plus 1 times x minus 3 if I clean it up a little. And then I can FOIL this stuff out. We got x squared plus 2x plus 1. And this one will have one more step. I got x squared. We got a minus 3x and a plus 1x, so minus 2x minus 3. And then we're getting there. We got x squared plus 2x plus 1. And here we got 2x squared minus 4x minus 6. Right? Finally, we're going to combine like terms and say, okay, I got 3x squared. I have negative 2x, and I have minus 5. So I want to find out all the times when this guy equals 0. Okay? So there's basically two ways you can figure out when this guy equals 0. One of the two ways is to use the quadratic formula, right, which you all should know and be able to use flawlessly. The quicker way is to do it by factoring. But if you aren't good at factoring with an a term, then this is going to be hard for you. But I want two numbers that multiply to make negative 15 and add to be negative 2. So that would be negative 5 and positive 3. So I put a plus 1 there and a minus 5 there. So first times first makes that. Last times last makes that. And outer is 3x and inner is negative 5x, which makes negative 2x. So yeah, if you don't know how to do that, then I guess do this, right? You'll still get the same answer. So either this thing equals 0 or this thing equals 0. So I got one easy answer of negative 1. The other one isn't much work. X equals 5/3. So those are the two places. Hold on a second. Do they fall on this interval? Yes. One's on the endpoint. That's totally cool. It wouldn't have been cool if it was on the other side of the endpoint. Hold on. I need to check our Rolles theorem real quick. I think we said, yeah, it has to be on the value. So, or it has to be on the interval. Yeah, anywhere on here. So it's allowed to be the endpoint too. So that's definitely on the interval, and 5/3 is like 1.2 repeating. So they're both between -1 and 3. So you got two winners. If you would have done that and gotten an answer outside of there, you throw it out. All right, so now we're switching gears to mean value theorem. All right, so this is the mean value theorem, and it looks an awful lot like the beginning of the Rolles theorem, where it starts off with f has to be continuous on your interval, on the whole thing, including the endpoints. And it has to be differentiable, meaning you take the derivative on everything except the endpoints. And it says, then there exists a number c on your interval. Now this one's a little different because isn't allowed to be on the endpoints. There has to be a point between a and b such that f prime of c equals f of b minus f of a over b minus a. What the heck does this mean? Like this thing here. Well, remember that a prime means instantaneous slope. And you know what this thing is? It looks like y minus y over x minus x, also known as average slope. So what this says is, as long as you can draw a graph without picking up your finger, or without picking up your pencil, then there has to be one place where the instantaneous slope is the exact same as the average slope of the whole time. So if I looked at a picture of this, let's say I started down here at A, like this graph goes on in both directions. I'm going to end way up here in B. Let's say I was taking, a route like this. Okay, let's say that's the crazy route I took there. At any point on here, you could look at, you can look at the average slope. That's the easiest thing to find. So the average slope would be if I connected these 2 points with a line and took the slope of it. Because this point is at b comma f of b, right? That's the x and that's the y, right? Dot, dot, dot. Here's f of b. And this is a comma f of a. If I drew a line over here, here's f of a. What this says is the slope between here, y2 minus y1, over x2 minus x1, this thing here is your average slope, rise over run. There has to be at least one place where my instantaneous slope is the exact same as my average slope. Now think about this. If you started drawing instantaneous slopes, I'm going to do it with a black pen here. Like the slope right here looks like this line. Slope right here looks like this line. Slope right here. None of those match my red, but if I drew a slope, instantaneous slope right here, that pretty much matches the slope of this. And then it starts getting more steep and then less steep and then comes back to here. So there's a few points on here. Like there's a steep slope and then it comes back to here. So there's a few points where it has the exact same slope. But it says there has to be at least one. This is actually the reason. Have you ever seen on the highway, like when you're driving down to Florida or Georgia or anywhere south, you'll see on the highway, let's say it's a divided highway, here's the median, here's my side. Okay, on the side of the highway, sometimes you'll see these big white rectangles. And sometimes they'll say speed enforced by aircraft. Okay, so if I were doing a top view of the road, I'd see these big white rectangles every now and then. So what they do is, the cops are using the mean value theorem, whether they tell you or not. So what happens is there's a helicopter or a plane somewhere up in the sky, and they're looking down. And your car, here's your car, here's the windshield, right? Okay, your car goes past the first white bar, and they just click a timer. And they time how long it takes you to get to the second white bar. And they can record it just to show that they're doing something honest. So what they can do is they know this distance. Let's say this distance was 1/4 of a mile, 0.25 miles. Well, if they have your time and how long it took you to go 1/4 of a mile, they can divide that distance by your time to get your rate. And that's not an instantaneous speed. It's not like a cop with a radar gun. A cop with a radar gun is getting your instantaneous speed. Like as you accelerate, as you slow down, each one of these little readings would be, your instantaneous speed. But this is an average speed. So they'd say, okay, if it took you 10 seconds to travel a 1/4 mile, they're like, I know you're speeding because that's an average of 70 miles per hour. And I know if you average 70 miles, or if I know you average 75 miles per hour, then there's at least one place on there, if the mean value theorem is true, that your instantaneous speed was 75 miles per hour. And you're like, no, officer, I swear that's not true. And they'll say, darn it, it's the mean value theorem. I can show you a proof of that. And you're like, please don't do that to me. And they're like, yes, I'm going to do that to you. So, they use math against you instead of a radar. So think of this as a radar gun, and think of that as your average, like your timing distance divided by time. Total distance divided by total time. So yeah, that's kind of weird. Weird but true. And it's why they can arrest you, because they say mean value theorem says if you averaged 80 miles per hour, there's at least one time you're going 80. You'd be like, no, officer, I was going 100, and then I slowed down when I saw you. And they'll say, well, that's not good, and you just admitted it, and we can now use it in court. All right, so I'm going to come back and do one example of how to check the mean value theorem, and it'll probably only take 5 minutes. So come back for the third installment of